For big data, what basically motivated us a lot was because big data is always right in front of our eyes, even more so as a service. Now, what that means is that as a service, that can include many different cases, as for consumer insights, maintenance, and even management. Big data as a service as a whole just really refers to a massive cloud based model of storage used to store, manage, process, and analyze large sets of data. This really interests us because of the fact that we use it on a day to day basis and never really realized it. And what is even more interesting is how it works. So, therefore, that is what gives us the motivation to really understand how all of it works and what all of it encompasses. And as engineers, we will most likely be dealing and working with a form of big data as a service. With such large data sets, it would be easy to believe the possibilities of failures or having the cloud or basically the model crash. Therefore, a lot of these organizations are looking for a very flexible and cost effective solution to handle the complexity, velocity, and the large scale of the modern era of data that all these corporations have and need to be able to store in a very flexible and cost effective way for them as well so they don't lose too much money. And here we will be exploring the concept of big data as a service and its architectural components, service models, all of the benefits, and also all of its limitations, because that's also a really big thing, especially with its new role in the advancing data driven world in this new modern era of big data as a service. All of these organizations really look forward to limiting the cost and expanding the flexibility and the complexity of it.
Current state of the art in big data as a service. The current state of the art in big data as a service is largely driven by major cloud providers such as Amazon Web Services, Microsoft Azure, and Google Cloud. These platforms offer fully managed environments where organizations can process large scale data sets without maintaining their distributed infrastructure. Technically, BDAAS platforms rely on distributed computing frameworks like Hadoop and Apache Spark. Hadoop provides scalable distributed storage, while Spark enables high performance in memory parallel processing. Many modern applications also incorporate serverless architectures, which compute resources where compute resources are allocated dynamically based on workload demand. Recent academic research focuses on improving elasticity, cost optimization, and system efficiency. Multi-cloud and hybrid deployment models are being explored to reduce dependency on a single provider. However, challenges remain, particularly in cost predictability, performance variability due to shared cloud environments, and concerns regarding data privacy and regulatory compliance. Overall, BDAAS has matured significantly, but ongoing research continues to address its architectural and operational limitations.
Okay, so for outcomes and methodology, in this section, I'll just simply walk you through our research approach and what we were trying to accomplish. So we started by reviewing published research from ACM and IEEE, then compared several of the leading big data as a service platforms currently available on the market today. Our evaluation focused on 5 key areas. First, scalability, with that being how well these platforms handle growth. And secondly, whether if it's cost efficient, so whether they're actually worth the investment or not, because nobody wants to spend pointless money. Third, performance, specifically looking at latency and throughput. Fourth, security and privacy, basically just to make sure everything is, safe and sound, simple. And fifth, vendor lock-in, meaning how difficult it is to switch providers or integrate with other systems. And so based on what we found across those 5 areas, we propose conceptual improvements aimed at making big data as a service architectures more flexible and sustainable in the long run. With that, we'll move on to our conclusion.
As we conclude, big data as a service represents a major shift in how organizations handle large scale data. Instead of maintaining expensive physical infrastructure, companies can now rely on scalable, cloud-based platforms built on distributed companies like MapReproduce. This model enables flexible storage, high performance processing, and pay as you go resource allocation, making big data analytics more accessible to organizations of all sizes. However, despite these advantages, it's important to consider the challenges that remain. Cost, cost unpredictability, variability in shared cloud environments, vendor lock-in, and ongoing data security and compliance concerns continue to limit the full potential of these systems. Moving forward, research must focus on improving cost aware scaling, strengthening interoperability across providers, and developing more efficient multi cloud architectures. Overall, this system will remain a foundational technology in modern data intensive computing and will continue to play a critical role in supporting AI, analytics, and data driven innovation.